All right, so we're here going to attempt this example. I have a student on the line that's going to help me out and guide me through it, or I'm going to do that for him. So we look at this series. The first thing that you tried was what? You tried to take
The nth term test.
nth term test, good. And what was the problem with that?
It was zero. Limit was zero.
And what does that mean if the limit of a sub n goes to infinity, it becomes zero? What does that tell you?
Nothing about the series.
Yeah, you have to try something else, right? It's inconclusive. So then you
Yeah.
recognize this to be an integral. This is an arctangent integral if you were to do it. So you can do the integral test, right? Is what you told me a second ago.
Yeah. Integral test.
And what were the three conditions for integral tests?
If it's decreasing, continuous. What's the last one?
And positive was the last one.
Yeah.
Good. So of these three, you only have to prove decreasing. Do you remember how to prove something is decreasing?
You can take the derivative.
Good. If you take the derivative of the sequence, what must it be?
Has to be less than zero.
Good. So if it's less than zero for all n, then you can say it's decreasing. So when we take the derivative of this over here, we're going to get, first let's rewrite it, bring it up to the top. Use the chain rule, bring that down in front. -1, rewrite your expression. Am I done? What's left for the chain rule?
No, you got to take the inside.
Good. Derivative of the inside is going to be
2n.
2n. Good job. So then this negative exponent comes back down, becomes positive, and then we have -2n over n squared plus 4 squared. So can I say that this is less than 0 for all n?
Yeah.
Yes, because what is the domain of n? What are we plugging in?
Playing 1 to infinity.
Good, the natural numbers. So less than 0 for all n, that's an element of the natural numbers. Okay? The other way you could have done it, quick side note, is a proof. If you were to compare n squared plus 4 and n plus 1 squared plus 4, which one of these is greater? The one on the left or the right?
The one on the right.
And then if I take the reciprocal of both sides, what happens to the inequality?
It switches.
It switches. So then
Because now it's getting greater.
So now what you've said is the original term is always larger than the next term. So that by definition is decreasing. Okay, either way you want to do it. Now we take a function. Let's make a function out of this thing. And it's going to be an integral from 1 to infinity of 1 or dx over x squared plus 4. So do you remember the formula for the arctangent of this thing?
Yeah, it's gonna be 1/2 arctangent x over 2.
Good. So the general formula for this would be this right here. If you have integral of du over a squared plus, or u squared plus a squared, it's 1 over a arctangent u over a. So if you plug into that, then you will get what this student just said. So it'd be, let's go ahead and, do you see that I did the limit? Don't forget this is an improper integral. You have to do that limit step because you can't have an undefined number in a defined integral. Okay? So don't forget the limit step. And keep rewriting the limit all the way down. And that's 1 over, 2 arctangent x over 2 plus c. Nope, not plus c. Why isn't it plus c? Why is
I'm not really sure, but I know it's not. You don't use plus C, but I'm not sure why.
because of the bounds. There are bounds. Anytime there are bounds, you don't use plus c on your integral. It's only if it looks like this and there's no bounds here and here.
Oh yeah.
That's when you use plus c. So this one has to be evaluated between b and a. Or actually, sorry, b and 2. Nope. Why do I have an a there? That a should be a 1, right?
Yep. One the T.
T or a or some constant. I chose b. Doesn't matter what your constant is. So now if we continue and plug in, I'm going to change to white. That way it doesn't blend in. We're going to have limit, and we're going to have 1/2 arc tangent you always plug in the top bound minus the bottom bound plugged in. Okay, so what would happen now?
Now you just for the one that has the variable B, you know that that arctan, the limit of it is the pi over 2.
Good.
Just arctan x.
Good, because we're going to get arctan of infinity over 2, which is still infinity, which you're saying that becomes pi over 2. Good. And then the right side, what happens to that? Do we know, is 1/2 one of the main angles that we deal with, reference angles? Do we know
Yeah.
it? Do we know an angle that has a tangent of 1/2? Not really. I mean, we deal with these main reference angles, right? So if you were to come up with your chart, none of these divide to give you 1/2. Oops, there should be a 4, 3, 2, 1, 0. Do you understand what I mean by that? So if you
Yeah.
look at this chart, this is sine then cosine for the first quadrant, basically. And it's all over 2. And then to get tangent, you divide these. And when you divide these, none of these will give you 1/2. So it's not going to be one of those main angles. It is something that you could get on your calculator, okay? But it's just not going to be something that you're going to know offhand without a calculator, is what I'm saying. So what you do at that point is you just use a little logic. And you know the integral test states what? It states that if you get a finite answer, does your series converge or diverge?
Converge.
Good. So here you need pi over 4 minus some number that you can get on your calculator. Actually have a calculator handy here. Let's see what we get when we plug in. So making sure we're in the right mode here, degrees, we would need to be in radians, probably, yes. And then you would do arctan of, where's my second function? 0.5, and you get, I guess I was in degrees mode, but this is a different calculator than I'm used to, so I'm trying to find how to switch to radians. There we are. So let's try that again. So second tangent of 0.5 Gives you 0.4636 in radians. So that times 0.5 gives you 0.23. Either way, the point is that we're going to get some finite number. Hopefully on the test they'll give you, I made this problem up. I could have started this series at 2, and if I would have done that, then this would have been arctangent of 1, and then that would have given you pi over 4 over here. So either way, as long as you get a finite number, you're right. Converges. Don't forget to write what test, okay? Integral test. Any questions?
Nope.
All right, let's try another one. Try this one. So any ideas?
Integral test.
Let's see. Could you do integral? No, not integral. What's the first one you should always try?
Nth term.
Yep. So let's try it. What happens when I do the limit as n approaches infinity? What do I get?
Good. Sine approach is 0.
Mm-hmm. And what is n?
Sine 0. So
And what is n approach?
infinity.
Do you recognize that at all?
Yeah.
It's one of your indeterminate forms. And whenever you get one of these forms that looks like this, if it isn't 0 over 0 or infinity over infinity, you can't do L'Hopital's rule. So we got to try to get this to look like that. All right? So let's go ahead and do it. What happens if we do that? Or do you know how to get there from this? Can we get it to look like this form? I think you and I did a problem like this, but it was sequence. We approached this problem when we were doing sequences. Do you remember?
Yeah, I remember now.
Okay.
You divided the
divide the n, right?
You divide the divide the whole thing.
And what does it become when I flip it to the bottom?
Comes shit. Can't remember Dessa.
It's okay. Don't be using my government name, please. It flips. Okay. Remember, when you divide by something, you flip it and multiply, right? So if I had this to get back up to here, what would I do? Well, I would flip this bottom term and I'd multiply by n. That's what I have right here. So what I can do is I can go backward with it and unflip it, if you will, and get it into that form and put it in the denominator. Does that make sense?
Oh, okay. Yeah.
Okay. So take the reciprocal of the least complicated one whenever you have this term and put it in the denominator. Now, at this point, you do get 0 of 0, and your first gut response might be to do L'Hopital's rule. But you should remember a Calc 1 identity. Do you remember your identity? Oops, no, it's 0 over 0, sorry. There's an identity with limits to do with sign.
No, I don't remember it.
It's okay. It says the limit as whatever approaches 0 of sine whatever over whatever, or whatever over sine whatever equals 1. As long as those boxes are the same thing and approaching 0. Do we fit that criteria right now?
Yeah.
Right? Because if I plug in infinity here, what happens? That goes to 0. And that goes to 0. Right? And they are the same thing, so what does this whole limit equal?
Like,
We got the
so we
same.
can just plug it into the other one, into how you have it for the identity.
We can. We can do a substitution if you want to. If you don't like it the way it sits, you could easily say let t equal.
Yeah. It's already in that form.
Yeah, but what I'm saying is, like, if you want to go ahead and do the substitution, let t equal 1 over n, that's fine. All you would have to do is, as x approaches, or I'm sorry, as n approaches infinity, what happens to t?
Goes in infinity.
As n approaches infinity right here, what happens to t?
Oh, n. I thought you said t. 0.
0, right? So then you could substitute everywhere you see 1 over n to get this new limit of t approaching 0 of sine t over t, and now you literally have that identity. And that will equal 1.
1.
Do you see that? What good does that do us? What good does that do us to get a 1? What's the big picture?
That it's that means it's divergent.
Divergent by what?
By the n. That's still an n-term test.
It is.
Divergent test.
Yeah, either or. Now, I'm missing a vital piece. I said that it diverges, and I said that what test, but I didn't say why. Make sure you just say why. You have to say not equal to 0, therefore divergent by nth term test. Okay? Any questions?
So that identity, we just need to know that.
Yeah, that was just that's a trick they might just pull out of, their butts, just to separate, the people that are really studying and the ones that are kind of studying. All right, you ready for the next one? Do you have this written down?
Yeah.
Are you writing them down? Christian, you're not writing these down, are you?
I am.
Oh, okay. All right, next one I'm going to give you is, let's see, let's do this. Let's go like this. And then we're going to do... All right. Can you see it?
Oh, shit.
I'm going to leave that on video, man. That's classic. Is it that bad? But see, that's what happens, Christian, whenever you let them intimidate you, because this series is actually not that bad if you recognize it for what it is, just like in life.
Away.
Okay, did something else happen in the room?
No, I was looking away, and when I turned back, I just saw that, and I was like, whoa.
Surprised you? Well,
yeah.
If you learn to see things for what they really are instead of the way things appear to be, then life is a lot better. Because this seems intimidating, but once you realize it's an alternating series test, because sine and cosine are just like a -1 to some power. Okay? What happens with sine and cosine? They oscillate between 1 and -1, don't they?
Yeah.
So that's an alternating series test. And there are two conditions for alternating series, both of which allows you to drop that intimidating part of the problem and leave you a much more reasonable problem. So it's just a scare tactic that a lot of professors like to do and teachers just to see if you're paying attention or not. You know, if you know AST and you're like, okay, well, I can drop that alternating part. It's a lot more reasonable. Then I
So no
suggest
matter
you
what was
do,
inside the sign.
yeah, no matter how funky it looks.
All right.
And then if you do the limit as n approaches infinity first, you will save yourself a lot of anguish, because if this equals to 0, you move on to step 2. But if it does not equal to 0, what you do is you would write, this is if, diverges by nth term test. Okay? So even though you started out with an alternating series test, the first step of the alternating series test is basically the nth term test of the sequence. Do you see it? Because this is the nth term test, right? Take the limit of your sequence as n approaches infinity. So if that thing doesn't equal 0, then the nth term test kind of takes over.
All right.
Okay? But in this case, we did equal 0, so we move on to step 2. Do you remember what step 2 of alternating series test is?
Any series. Oh, let me look at my notes.
It's all good. It's proved that it's decreasing. So a sub n has to be greater than a sub n plus 1. And you already know how to do that, right? You told me in the earlier problem.
Yeah.
And it seems
Could you also
like,
just do the derivative there?
Yeah. Whichever one's floats your boat. Okay. So if you did, let's just do it off to the side here. If you do a sub n is 1 over n, so a sub n prime is what? What does that equal?
Oh, a sub n prime.
The derivative of your... So let's rewrite it maybe. Negative
2 over n cubed.
No, you're getting a little... Oh, it was n squared. My bad. I'm tripping. So it should be n to the -2. Yeah, I thought I put a -1 there. So -2n to the -3, which becomes, you're right, -2 over n cubed. So can we say that's always less than 0?
Yeah. Oh, well.
Yeah, because... Yeah, no matter, it doesn't matter whether this is odd or not, because
I forgot the negative was there.
the negative is there, and we're always plugging in positive numbers for n, right? The natural numbers is the natural numbers is the domain for all n element of the naturals. Okay. The other way is a proof, which is actually pretty easy in this case. I'll do that up here. If you compare n squared and n squared, or n plus 1 squared, which one's bigger? That one. Then if you compare the reciprocals, which one's bigger? The other one. So you can see they're both pretty easy in this case. So don't get too accustomed to just one way of doing it, because some scenarios the derivative will not be a clear indication, whereas the proof will be much easier. Okay? So now that we've passed the two conditions for AST, alternating series test is one of the tests that you have to prove convergence or divergence of just the series, or just the sequence as a series. What do I mean by that? Well, there are certain scenarios in which you'll pass the two conditions for AST, but then when you look at this, it'll fail. Okay? So what you have to do is ask yourself, does it converge all the time? Absolutely. Or is it just conditional to the alternating series test? Does it pass the AST and then fail something else? So what the question becomes is, what kind of test is this? Okay. You should watch the videos, buddy. They'll help you a lot. So 1 over n to the p is a p series, and anytime p is greater than 1, it converges, and anytime p is less than or equal to 1, it diverges. Of all the series that are compared to 1, p series is the only one that diverges when it's less than 1. All the rest of them converge, but p series does not. Okay? So in this case, Rp is equal to 2, therefore it converges. So you'd write, therefore, convergent P series, because P is greater than 1. All right? So the big picture then you would say is, therefore, absolutely convergent. I'm trying to figure out where I can squeeze it in. Therefore, absolutely convergent. Now, had the P series been, let's say this was a 1/2 instead of a 2 at the bottom exponent, and P was less than 1, it would diverge here, right? Do you agree with that statement?
Yeah.
If this was a 1/2, it would diverge, right? So
Yeah.
then you would have, instead of absolutely convergent AST, you would have written conditionally convergent by AST. Do you understand what I'm saying?
Yeah. Because it only
Okay. The only condition that it converges under is AST, but the other conditions it fails, it diverges.
So this is for alternating series for the
Yes.
since
Yes.
they have that sign.
Pardon me? I didn't hear that last word.
So it's only for alternating series.
Yeah, where you have to do absolute convergence. Yes.
All right.
Can you handle another one? Is your brain getting tired?
I got it.
Okay. Do you need me to... Have you written this one down?
Which one?
The one we just
Yeah,
did? You've been
I
writing
will.
it down?
Yeah, the absolute and convergent. Yeah.
Okay. All right. Let's see which road we should go down next. So I'm thinking comparison test is going to be on there. So what I'm going to do is I'm going to approach that same problem we did earlier as a comparison test. The one that was 1 over n squared plus 4. Remember that one?
Yeah.
First one. So if we look at that one, limit comparison says come up with another series that looks like the highest power basically of the top and bottom of your series. So in this case, your B sub n is going to be 1 on top, and the highest power on the bottom is an n squared. Do you see that? Do you see how I came up with that?
Yeah. You took the n squared because it would have the greatest power.
Yep. And there's no n on top, so I just put the 1 over there. Then what you do is you take the limit as n approaches infinity, and you look at A sub n, which is your original series, over B sub n. And if that answer, which a lot of people call rho, is an element of 0 to infinity, okay? Or another way to say it is it's positive and finite, whichever one makes you happy, both will be accepted. Then, if your answer is in between there, then A sub n acts just like B sub n. And what kind of series is B sub n? What is this?
That's the same one we just know it ain't because it didn't have the top. It doesn't have the top thing. So
Did the last one have the top thing?
yeah, because sign. But then we took it out.
Didn't we
We
get
took it
rid?
out.
Yeah, and we looked at that, and then that was what kind of series? Can you see the screen?
Yeah,
What kind of series is that I'm pointing to?
alternating series.
No, no, right here.
Yeah,
P series.
but I don't get it.
And we
So,
said that it.
but wouldn't so now
Go
the
ahead.
whole sign thing, the alternating on top, doesn't matter no more.
Well, that was the last problem we were doing. Okay. And on
Yeah.
that last problem, it never mattered from the get go. Once I discovered it was an AST, what's the first thing I did? I crossed it out. I just looked at the absolute value of it. And I looked at that from then on, right? Look right here 1 over
Yeah.
n squared. I never had a sign in there. 1 over n squared, right?
Isn't
So,
there a different way, different things you follow when it's an alternating series, like from the beginning? You know what I mean? And then you took it out, but it was still in the you know what I mean? Like now you took it out, but
yeah, so,
it's still
okay.
the
So,
original equation.
yes, yes, you're right. It is still an alternating series, but within the alternating series thing, what was the last thing we did? We looked at it without the alternating part of the problem as a series, right? Right here. And we said
Oh,
that was a
okay,
P
okay.
series. So within the alternating series problem, there was a P series problem.
Yeah, I'm
You
not too
see that?
familiar with the P series.
Okay. Well, all it says is if you have 1 over n to some power, just n to some power, it can't be anything else added or subtracted to it. If it's greater than 1, it's convergent, but less than or equal to 1 is divergent. Okay? So if we
All
look up
right.
here, this is a convergent P series because P is 2, which is greater than or equal to 1.
All right.
Okay? So now when we do this limit, let's see what happens. So now if I flip and I multiply, do you see how I did that?
Yeah.
Or if you want to just multiply top and bottom by n squared, whatever makes you happy. Either way, you get the same thing. This cancels on the bottom, right? So what's the first step in the problem here? In this limit?
Can, can't you just divide it all? Do the
Yeah, you're right. We're going to divide out the highest power. But first, what you should do is plug in and then let the grader
oh
know that you understand it's an indeterminate form. And then either do L'Hopital's rule or, like you said, divide out the highest common power. So when you do that, you're going to get n squared over n squared. And then to figure out what's left, you're going to do had originally over what you're factoring out. So n squared and n squared cancel, give you 1, and then you're left with 4 over n squared. Do you understand what I'm doing there?
yeah.
And then you cancel the n squareds. And now that I've rewritten the problem, I reapply the limit. And what happens when I get that?
You get 1.
You get 1 because this bottom term goes to 0. Any finite number over an infinite number. 4 is a finite number. So that will give you 1. Is 1 an element of 0 to an infinity? Does it belong in
Yeah.
this set? Yes, it does. Right? So you could either say element is 1 is an element of 0 to infinity, or you could have said 1 is positive and finite. And your conclusion will then be, therefore, A sub n converges by LCT because B sub n is a convergent P series.
Hey, so will they take points off for not? I don't think they don't care. Do they care that much about that showing that you know that showing like what you said, showing the greater that you know it's indeterminate, infinity over infinity?
I don't know, man. I'd rather not just leave it up to chance. I'd be mad if I lost, 2 points or whatever on problem just because I didn't write this down. Just go ahead and do it. Some graders
All
are
right.
really like retentive, really, really nerd. I don't want to say the nerdy, but because I'm a big nerd myself. But some of them are dysfunctional, if you will, and they kind of are really picky about stuff like that. So
All right. Just to be
I
safe.
would go ahead and just do it. Yeah. All right. So let's recap what we did here. We came up with another series just by taking the highest power of top and bottom. And this was a P series because it's 1 over n to some number with nothing else there. And that number was greater than 1, so therefore it's a convergent P series. And then we take the limit of A sub n, which is your original, over B sub n, which then allows you to simplify. Once we simplify and saw it was indeterminate, we factored out the highest common power, saw that our limit indeed equaled 1 and is an element of that set. So therefore, because it's positive and finite, we can say it converges by LCT. Any questions? Any questions?
No.
All right. You want another one?
What'd you say? Your mic cut off.
Would you like it? My bad. Would you like another problem?
Yeah. Let's go for another one.
All right.
Last one because I got class at 5:30.
Okay, no worries. Let's see. Go. What do I do here?
Oh, I've seen this before. So it can be. Wouldn't that just go to 0? If you do take the limit of that. So
It would go to 0, so nth term doesn't work.
yeah. So then you gotta do another one.
What else?
Feel like you could do maybe a comparison test with that one. Did you?
You probably could, yeah. I don't see why you couldn't do that. Let's see. I think it would be easier, though, if you tried this guy. What does GST stand for?
Geometric series test.
Yes, sir. What does the form of the geometric series look like?
It's
The general form.
a AR to a power to N, I think. Oh yeah, yeah, yeah.
If you it's to the you can do it to the end, but this has to be a 0. Since I started at a 1, I would recommend doing that n-1.
All right.
So your goal would be to make that a n-1. So the first thing I suggest is getting rid of that +1 right there. What does it mean when we have a +1 in the exponent?
I don't know what it means.
You didn't take my advice of working on your exponent rules, did you?
Nah, I know, I
If
know.
if your box if your boxing coach told you to work on your let's see, what's a good boxing thing besides jab? I used jab on you last time.
That
If
left
he
hook.
told you to always keep work on that left hook, you can knock people out. And now, but it's got to be something a little bit more defensive, I would think.
That bob and
I'll come
weave.
up. Yeah, I was gonna say something about that bob. After you throw a big punch, make sure you bob and weave just in case. Or how about a counter? After I don't know. I'm too tired to come up with a metaphor. But point being, I gave you some advice, and you didn't follow it. Thanks.
It's been
So
test lately. It's been over to test right now.
it's okay, man. Just get it done. What's your major?
Computer science.
Okay, you're gonna see a few more math classes, I'm sure, after this. So might as well get it out of the way.
Yeah, I'm gonna watch all your videos
What it
tonight.
means whenever. Okay. What it means, anytime you got exponents added like that, you had them once multiplied. All right? So that means you had an e to the n times an e. That's how you got to the e to the n plus 1. So since they're in the denominator, what I did is I rewrote it as 1 over e times 1 over e to the n. All right? So now the question becomes this. How can I get this n to become an n minus 1?
Let's do e to the. You already did it. Oh, that's yeah. Okay.
No, that was for this one right
Yeah,
here.
that's the add one.
Yeah. How can I make this an n minus 1? What would I need to multiply by? I'm pulling out another.
E to the n.
1 over e. 1 over e. So if you think about it this way, what would I need to multiply e to the n minus 1 by to get that e to the n? Well, we need another e to the 1 power, because what do you do when you multiply like bases?
You add them.
You add. What do you do? I'm sorry, the mic broke up.
You add them.
What are you doing? No, me desta.
You're talking about the
Sorry, I couldn't
powers.
resist that bad joke. Yeah, no, I was giving you a bad joke. You don't get it?
Or
I
what?
said, what do you do when you multiply like bases? And you said, you add them. And I said, no, me desta. You add them? No, me desta.
I don't get it. That's the.
You just said my name was Adam, and I was telling you, no, me desta.
Oh. Okay.
Worst, the worst joke ever. I know. You don't have to tell me. It's horrible. So it's
It was
pretty
so
bad
bad I
when you got to
laughed.
explain your joke. Nah, bro, it's pretty bad. I got to explain it. Every time I use that joke, I got to explain what I'm talking about. Every once in a while, somebody's got a bad enough sense of humor where they get where I'm coming from. But here we got an e to the 1 and e to the 1 that becomes e squared. You just add these exponents. And then now we have it in the right form. So what is your a?
It's one e to the n. I mean to the 2. That's your a n.
1 over. Good. That's your a. And then we can say that 1 to any power is n minus 1. So we can rewrite that whole thing as 1 over e.
Makes your R 1 over
raised to
E.
the n minus 1. Very good. Now the question is, does that converge or diverge?
That goes to infinity. So it's greater than 0.
This one is compared to 1. So if the absolute value of r is less than 1, it converges. But if it's greater than or equal to 1, it diverges.
So if it's less than
See it?
1.
It converges.
All right. I see
And
it now.
greater than or equal to 1. So in this case, 1 over e is roughly 0.37 if you put that in your calculator, which is less than 1. Therefore, converges by GST. All right? Now we can find the sum. You might be asked to find the sum of the GST.
And then you use that formula. That A minus
Sum is equal to A over
A
1
minus 1
R.
over. Oh, shit. I had it backwards.
That's okay. A over 1 minus R. So in this case, A was 1 over E squared. R is 1 over E. Do you know the easiest way to simplify that? If you just multiply the top and the bottom by the... Go ahead.
By E? I would have just put it in my calculator.
Actually... Okay. Yeah, that's what most students would do nowadays. But if you take the common denominator of the top and the bottom between E squared and E is going to be E squared. And when you multiply both top and bottom by E squared, what happens is they cancel on top, leaving you 1. And then on the bottom, you're going to get E squared minus E. That's what I would have given my answer. Because you can't be guaranteed you can have a calculator on the test, right? Some professors don't even let you.
I think they say that they always let us have one. But you're right.
Scientific, basic.
It's better to get that answer.
No worries. So I hope I've cleared up your understanding on some of these. If you want, after class, we can meet back. Start working on the review problems that I'll post here in a second, okay?
All right. When are you going to post them?
Are you checking? As soon as I get off with you.
Where are you going to post them, on the Facebook?
On the Facebook group, yeah.
And
Integral Cal group.
And you said something about a review?
Yeah, I'll just be doing online reviewing tonight. So just what time you get out of class?
6:45.
Okay, if you want to meet at 6:45, 7. Actually, what I recommend you do is watch the videos some.
Yeah, I was going to tell you that.
Between 7 and 8, watch some videos, and then like 8 to 8:30, try some of those problems, and then like 8:39, I could.
I think I'll be good. I just need to watch all the videos because I understood everything. I just need to review through it and if I can remember it right, like every detail, and then I just go through the review.
All right. Well, I recommend when you're watching them, take good notes on the concept videos, and when you do the example videos, pause it, try the example, then watch the solutions.
All right.
All right, but you got my number. Text me if you need some help.
All right, I will.
All right, brother. Have
a
good day.
Appreciate it.